You are welcome to AI Everyday Virtual Bootcamp Season 2. My name is Ezekiel, and before we start today's class, let me quickly introduce you to Data Science Nigeria. Data Science Nigeria is a registered non-profit organization whose vision is to build a world-class artificial intelligence knowledge, research and innovation ecosystem, such that in 10 years, Nigeria will become one of the top 10 AI talent or knowledge destinations with 20% GDP multiplier impact. And we are doing this by creating a business use application and establish AI startups. These are our key numbers in 2 years. As you can see, we have spent over 2,000 hours on free classes in different data science and machine learning applications across states of Nigeria. We also have free introductory machine learning classes, which we organized in 30 cities, and this has reached 5,000 students. We've also created 4 innovative product ideas. We run the biggest AI learning program in Africa, in which we segment our classes for beginners to professionals. We also run AI Everywhere for 6 weeks, in which we teach introduction to Python programming and machine learning. And this has reached more than 1,000 students in 17 cities. Our Artificial Intelligence Bootcamp is the biggest and most competitive intercampus learning platform, where we have international and local experts who facilitated so many sessions. You can download our annual report at this link. We've also trained companies such as Shell, FCMB, and Azamanzad. These are some of the works that our attendees did in the class. We have courses on robotic process automation, data engineering, game theory and mechanical design. We also have courses in data science for marketing, data science for HR, data science for banking, and many more. You can kindly visit this link to learn more about our trainings. Before we go into today's class, let's quickly hear from some of the attendees of our paid classes.
Okay, so I chose data science because, it's the future.
The vision of DSN, I identify with it. It's something I can relate with, the vision of wanting to create a hub for data scientists in West Africa. It's something that is highly needed.
Okay, so far so good. It has been a wonderful one. I was able to learn the use of data to interpret data, to predict the future, definitely.
My big take home is probably sentiment analysis and then the use of big ML.
Today we did data visualization, dealt extensively with Power BI. There's a whole lot I can do with it. Things that we've been trying to analyze, I can now visualize it and it will make more sense to my audience.
Big ML majorly, it has been my own major takeaway, and the lectures were so broken down such that anybody can understand it.
So what Sheon told me is lesser than what I even experienced there. The facilitators, they took us like children. It was like a dummy taking the course.
Tell everybody I come in contact with, especially young people in school right now, jobs as we know it will no longer exist. So you should get trained, in one of the technical skills. It could be data science, machine learning, artificial intelligence. That is the future.
So for me, DSN, the vision, is something that every forward-looking Nigerian should identify with.
chose data science because, I mean, it's the future. And then, of course, when you look at the way that the world of work is evolving with the statistics, I mean, we have several statistics, one of which I saw recently saying that 47% of jobs as we know it today will evolve or no longer exist. So it's just only natural that you evolve and acquire skills that are in time with, the time, and then, of course, what the future prescribes. I came in contact with Data Science Nigeria for the first time. I think your very first boot camp. I was supporting a client at the very first boot camp that I held in Lagos. And since then, Data Science Nigeria has pretty much been on my radar. I've been keeping tabs on the company. And then a few times, I think after that event, I Googled Data Science Nigeria. And I saw a number of the trainings that you had planned out, and they looked quite interesting. My very first class, of course, we learned about the types of data. And then by the second class, what I really like about the class is the fact that it's very hands-on. So now, I mean, when someone comes and says big ML, I'm looking at you like, oh, I know what that is, With big ML, we're able to evaluate models, and then went on to the next class, which we had to use text mining tool, which was Orange. Tell everybody I come in contact with, especially young people in school right now. Jobs as we know it will no longer exist, so you should get trained in one of the technical skills. It could be data science, machine learning, artificial intelligence. That is the future, and of course you have to take the Data Science Nigeria. Now here's why. One, I see that there's a whole lot. First off, the vision to get 1 million people, 1 million AI talent out of Nigeria, I think it's very laudable personally. I'm quite aligned with that vision. I think it's a good one. And then I can tell you for free that the training that you get is actually relatable. You can use it from the get-go. It's not all theory. And that's exactly what you have here. So I highly recommend Data Science Nigeria for your data science or AI or machine learning or any other fourth industrial revolution skills.
Welcome to Beginners R for Data Science. In this class, you will learn how to program in R and explore opportunities. My name is Ezekiel Ogundepo, and this is my Twitter handle where I tweet stuff in R, Python, and Excel for data science. And this is my GitHub repository, and here is my website. I will tell you to relax because programming in R is cool. But if you doubt me, you can ask our convener, Dr. Olubayo Adekambi, who is a passionate lover of R. And this is Adley Wickham, the chief data scientist at R Studio. Adley Wickham and his team have developed a lot of packages in R, for example, Tidyverse. And this is Gift Afolayan, a passionate user of R at RITA Nigeria. In this class, we look at the history of R, R for data science, R as a calculator, variable and assignment, basic data structure in R, and after everything, we look at the summary of what you have learned today. What is R? R is a dialect of X, and X is a language that was developed by John Chambers and others at Old Bear Telephone Laboratory. One key limitation of X language was that it was only available in the commercial package called X+. That is, X language was not free. And that was why in 1991, Ross Iker and Robert Gentleman developed R programming at the Department of Statistics, University of Auckland. R version 1.00 was released to the public in the year 2000. This year, 2020, marks the 20th celebration of R version 1.00, and since year 2000, where they created R version 1.00, 80 versions of R programming have been released so far. What is R? R is a programming language that can be used for data cleaning, data analysis, and data visualizations. These are companies that are using R for data analytics, and in this list we have KPMG, KeyBank, and Deloitte. Before we go into the practical session, let's quickly define data science. Data science is an exciting discipline that allows you to turn raw data into understanding, insight, and knowledge. As you can see this definition, in data science, we transform raw data into understanding, and thereby we give insight. The goal of this class will help you to learn the most basic understanding of R, which will allow you to do data science. According to Hadley, these are the data science phases. The first thing in data science is to import datasets. Tidy. Tidy means clean your dataset in a ready-made to use. Transform. Transform is a process at which you create a new variable from an existing variables. Visualize. In visualization, you carry out EDA, which means exploratory data analysis. And in model, you train your model, and at the end, you communicate the result and findings to the stakeholders. This is our programming interface. And here is R Studio. Programming is not friendly in this interface, and that is why R Studio created the one that will make it friendly. R Studio is an IDE, which means Integrated Development Environment for R. R programming supports Windows, Mac, and Linux. And here are the instructions that we can follow to install R programming for Windows, Mac, and Linux. Let me quickly show us how we can install R for Windows. To install R for Windows, we come to this link, this website, and click this. So after saving it, this will download the R version 3.6.3, which is the latest version of R. I'm not going to download it because I already have it installed. And here it is. As I said before, the programming in R is not easy in this place, and that is why we are going to download R Studio. So to download R Studio, we are going to come to this page and click here for Windows. But for other users, we can download R Studio for Mac by clicking this place. And for Ubuntu, you can come here to download this. When you first launch R Studio, this is what you are going to see. But let me show you something. Come to this side and click Scripts. So now we have 4 panes in R Studio. This place is called Editor, and this place is called Console, and here is when you visualize anything in this place, you are going to see it displaying here. And this is where the history of whatever you are coding will be saved in this place. In this editor, this is where you are going to save your scripts. For example, let me say D is equal to 7. So by pressing Run, we are going to have your result in the console. And when I ask for the value of D, you can also use Control Enter to run it. You see that D is equal to 7. Don't worry about this. I'm going to explain it later. Alright, as you can see, the history of everything we are running is showing here. Okay, now to ask for the help in R Studio, you can use question mark and whatever you want to find. For example, let me look at print. Print is a function. Let's see what print does. I'm going to run this by pressing Ctrl Enter. You see, to print values. You can read through this to understand what print does. Now let me go back to my slide. Let's see how we can use R as a calculator. We can perform so many arithmetic operations in R. For example, addition, subtraction, multiplication, division, exponentiation, and modulus. Let's go back to the R Studio and see how we can do that. Let's see how we can calculate 6 plus 12 in R. By coming to the editor, we are going to type 6 plus 12. Then we are going to run into the console by pressing Ctrl Enter. As we know, 6 plus 12 is equal to 18. Can you also do this one? 800 negative 900. Come to the editor and type 800 negative 900. 800 negative 900. Press Ctrl Enter to run it. Henceforth, I will be running my code in the console, and you, in your own place there, you can be typing it in the editor so that you can save it for later use. Now for multiplication, 4 times 5 is equal to 20. You can come to the editor here and type that. For division, R uses this sign for division. Let's see it. 2018 divided by 2. I'm going to press Enter to run this in the console. Now for exponentiation, you can do exponentiation by using caret in R. So let me come to the console and press 2 raised to power 3. The result is 8, and we have it here. Now for modulus. This one means that what is the remainder when you divide 20 by 3? You know that the remainder is 2. Let's see, 20%, and 3. The remainder is 2. For square root, R uses sqrt as a function for square root. Let's see it. Sqrt of 4. The result is 2. Can you also try this in your own place there? This is square root of 4 raised to power 2. Copy this code to your editor and get the results. Comment in R. R uses hashtag to add a comment. It is important when you are coding to always comment your code so that others can understand what your code is all about. For example, here I'm going to write R as a calculator. As you can see, this is a comment. R ignores any hashtag sign. So let me also come here by saying 3 plus 9 is equal to 12. Now let me put it here so that you can see how R ignores as sign. This adds 3. This is the sum of 3 and 9. As you can see, R ignores hashtag sign because R knows that this is a comment. How do we assign a value to a variable? We know that a basic concept in statistical programming is called a variable. A variable allows you to store a value or an object in R. For example, let's say age is equal to 9. Then let me run it. Control enter to have it. You can see you are looking for 9, but nothing shows in the console. But you can come here and press enter. You see that now, you see that age is equal to 9. Why this sign? This sign is assignment sign for R. Although you can also use age is equal to 9. And when you run it, you have the same result. But we, the users of R, prefer this to this. So henceforth, you can be using this sign as assignment. And the shortcut for this sign is Alt minus. Let's try another one. Let's say value is equal to 90. Run it, then ask for the value of 90. Once you have assigned a value to a variable, when you need that value again, you just call out for the variable name. You see again, value, and let's say I want to add 90 to value again. I can just say value plus 90. You see, the result is 180. If I want to assign this result to another variable called let's say length. You see now, length is equal to value plus 90. So if I call for the value of length, now I see that it is 180. I'm going to give you this one as assignment. Number 1, you calculate, you assign x, you assign 3 to x, assign 4 to y, assign 10 to z, then calculate x plus y. Z minus x minus y, x times y, z raised to power s. Can you do that? Okay, let me see. Alright, x plus y is 7. Great. And these are the result of z minus x minus y. The result is 3, and x times y is 12, and z raised to power x is 1000. Naming rules for variables. The best naming convention is to choose a variable name that will tell the reader of the program what a variable represents. As you can see here, I said age is equal to 9, and also here length is equal to value plus 90. So these are good variable names. Now, what are the conventions for naming a variable? Number 1, all variables must begin with a letter of the alphabet. As you can see here, we have alphabet A, V. After the initial letter, variable names can contain underscore or a period, and also a number. Let's see this one. It's saying that, let's say we have age of student, age underscore student, age underscore student, let's say is 15. See, now this one is saying that after the initial letter, variable names can also contain underscore or a period. As you can see, I have underscore here, and R accepts that. No spaces or special character are, however, allowed. So this one is saying that you cannot put a space in a variable name. So let's see here, age class 50. We have an error. Why? Because this one has a space. Uppercase characters are different from lowercase characters in R and also in Python. So this one is saying that R and Python are case sensitive. These are samples of acceptable variable names in R. You see here that this thing follows our naming convention, and also this and this. But in this place, can you tell me why this one is not acceptable? Okay, because of this parenthesis. What about this? Space. Great. As you can see here, that no spaces or special characters are allowed. What about this one? Number. You can see that there is a number here before term, and that is why this one is not acceptable. The same thing with this one. Basic classes of objects in R. We have numerous atomic classes of objects. For example, decimal like 4.7, which you also call a float, and I'll call this one numeric. We also have natural numbers like 4. You know this is an integer. I'll also call integer a numeric. Boolean. We have Boolean like true or false. So Boolean can either be true or false, and I'll call this logical. We have text or string, which I'll call characters. Text is like alphabet. For example, when you have, let's say you have a name, you put it in double quotation. Let's say you have Tomiche. If you call this out now, this is a character. We can use a function class to check for the class of objects. Now you see that this one is a character. Why? Because of this double string. And what about 4.7? Let's say k is equal to 4.7. If you run this, let's check for the class of k. Class of k is numeric because this is a number. As I said, integer 2 is also a numeric. Let's see. Let's call it j. J is equal to 8. Let's check for the class of j. The class of j is numeric. Boolean. We know that Boolean can either be true or false. Let's call it u. U is false. Let's check for the value of, for the class of u. Class u. This is logical. What about true? Let's say y is true. Let's look for the class. Class y is also logical. What about factors? Factors are categorical variables that have levels. For example, you know that gender can either be male or female. Male or female is the levels. Male or female, male or female is level of gender. So now how do we create a categorical variable in R? Although we are not there now, but we are going to be there. Let me just show you how we can create a factor in R. Let me say gender. Gender can either be a male or a female. A male or female. I'm going to tell you what this one means later. Let us run this one. If you look for the class of gender in this case, R is going to tell you that it is a character. Why? Because of this quotation. But how do we convert this character to a factor? So we can use factor. Let's do like this. Let's say gender. If you use factor here and copy what you have in this place. If you run it again, and if you look for the class of gender, it's going to be a factor. As you can see, it is a factor because of these levels. Let's check for the levels of gender. Gender, you see, female, male. You can ask, why do we have 1 here? This 1 here is showing that this is number 1 and this is number 2. So if you have a lot of elements, this one is going to change and it will be easier for identification. So if you have a lot of stuff here, this one is going to count it for you. This place is number 1 and the following is number 2. We are going to see it in the other examples. Okay, we have done this. This is class numeric. This is class numeric. You know this is a string, so this will be a class character. And this is what? Boolean. Good. That is why we have logical. We have shown this one in this side here. And we know that the levels of gender are female and male. Basic data structure in R. We have 4 basic data structure in R. The first one is a vector. And a vector is a collection of elements of the same class. We've known what a class is. We also have matrix, in which all columns must uniformly contain only one variable type. We also have data frame, which we call data.frame. And in data.frame, the columns can contain different classes. While the fourth one is list. List can hold objects of different classes and lengths. Let's see what a vector is. Vectors are one-dimensional array that can hold numeric data, character data, or logical data. So how do we create a vector in R? For example, you see that we have 1, 2, 3, 6, 7, and 10 here. If you say that x is equal to 1, when you run it, you say y is equal to 2, you run it, you cannot be assigning different variable for this. And that is why vector will assign everything for you in one line. So let's see. Numerical. You can also call it any other variable name you like. What do you like? Okay, number. Alright, let's say we have number. Press Alt minus to have assignment sign. Then you can concatenate this one together by using a small c. So c, then 1, press comma. Then after comma, it's a good practice to use space. Press 2 again, comma, space. 3, comma, 6, comma, 7, comma, 10. Run it. Let's look for what we have assigned to number. Now, in this case, you see that we have all this. And this has how many lengths? You can check for the length of number by using length. Length is a function to get the number of elements in a vector. You see, this has a length of what? 6. So what about character? How do we assign all these characters into a vector called character.vector? So we can do the same thing by creating a variable name. Let's call it name. Let's assign all these names to this vector. So the first one, let me call it Tomise. Second one, don't forget to put a space. Let me call it Lolo. Let me call this one Halima. Let me call this one Michael. Don't forget to put the double quotation, because I will throw an error if you don't put quotation in a string. Let's run it. Let's look for what is in the variable name. You see that we have all this. Can you check the length of name? How many elements are in this vector? You are counting it by hand. 1, 2, 3, 4. Yeah, 4. It has a length of 4. Let's use how to do that. Yeah, 4. As I said, adding a space behind the commas in the concatenation function improves the readability of your code. Now, how do we name the element of a variable? Because if you have this one, let's say age, let's put it in a concatenation. Let's say age of students in a class. We have 10, we have 11, we have 15, we have 8, 20. Oh, 20 is too much. Let's say we have 17. If you call for age, you have all this, but you don't know what this term means. This 11, you don't know what it means. That is why you can name this vector. Let me name it so that you can understand better. So we use this function called names, and in these names we are going to put the name of your vector, age, and then you assign the name for each of the elements. So let's see here. This 10 is for Tomise. This 11, let's say, is for Lolo. 15 is for what? Okay, Kunle. And 17 is for Shola. Okay, Shola. So let's run it. And now let's call out our variable name called age. As you can see now, we have Tumise, who is 10 years old, Lolo, 11, Shola, 17. Is it clear now? We use this function names to assign name for each of the elements in our vector. How do we do arithmetic with a vector? It is important to know that if you sum two vectors in R, it takes the element wise. How do we do arithmetic with vectors? It is important to know that if you turn two vectors in R, it takes the element wise. So you sum the element in a row wise. Let's see. So for example, we have a vector A, this, vector B, this, and now we have a vector C, which is the sum of A and B. So what C will do is to calculate the sum of the row wise of the elements in each vector. Let's see. 1 plus 6 is going to give you 7. 2 plus 7 is going to give you 9. 4 plus 9 is going to give you 13. And 5 plus 10 is 15. Is it clear? Oh, it's confusing you. Okay, let's see it here. A is a vector of 1, 2, 3, 4, 5. Let's run it. B is a vector of 6, 7, 8, 9, and 10. B is a vector of 6, 7, 8, 9, 10. Can you call for A? You see, this is 1 to 5, and B is 6 to 7. And we want to add each element of A and B together. So that is why we say A plus B. If you press your Ctrl Enter, you have this. And we are saving the result of this to C. So by assigning a variable C. Now you see. Is it clear now? Alright, great. How do we select element of a vector? So you can select element of a vector by using a square bracket. It is important to know that the index of R starts with 1. For example, you know that, let me show you. A is this, and this is index 1, index 2, index 3, index 4, index 5. What about C? Let's see. C, index 7, 9. Vector selection. To select elements of a vector, you can use a square bracket in which you are going to indicate what elements to select. For example, to select the first element of a vector A, you type A square bracket 1. So let's see. We know that our A is this. So if I want to select the first element, I'm going to use a square bracket after A and press 1. So this one is going to return the first element for me. Let's see for C. So C, these are the elements in the vector C. So let's extract this 11 out. 11 is in position what? 3. Yeah. The index of R starts with 1. This is 1, index 1. This has index 2. This has index 3. This has index 4. And this has index 5. So if I want to get 11, I'm going to use C square bracket 3. You see, this is 11. What about the last element? 15. You're going to count it. 1, 2, 3, 4, 5. Good. So you say C square bracket 5. And here you have 15. Can you tell me what this one do? A square bracket A greater than 3. Okay, let's do it together. First of all, let's know what is in A. A is a vector of 1 to 5, right? So A greater than 3. Let's see. A greater than 3. This one is going to tell you which of the elements in A are greater than 3 by throwing a Boolean value. You see, for example, the first one is 1, and 1 is not greater than 3. That is why this one is false. 2 is not greater than 3. That is why this is false. 3 is not greater than 3. That is why this is false. And 4 is greater than 3. That is why this one is true. 5 is greater than 3. That is why this one is true. So this A square bracket A greater than 3 is going to return the element whose value in this place are true. And they are what? 4 and 5. Let's see. 4 and 5. Is it clear to you now? Okay, great. So to clear your screen in the console, you can press Ctrl L. Ctrl L. Ctrl L will clear your screen. Now, how do we create some special vectors in now? For example, we have 1 to 10. This is a vector, you know, it's from 1, 2 to 10. But you can't just be typing 1, 2, 3 for this vector A. There's a way you can do it. Let's see. The first method to do that one is to say A, assign it like this, alt minus, then 1 to 10. Run it. You can call out for the values. You see, this is it. You can also use sequence. Sec is a function in now. Let's see. Sec. Let's look for help. Sec. As you can see, to generate a sequence, you use sec. And in this case, we want to generate a sequence from 1 to 10. This sec has 3 arguments. The first one is from, where you want your sequence to start from. 2, where you want your sequence to end. And by is the increment. So let's see. Sec. I want my vector to start from 1 and end at 10. Then with an increment of what? 1. As you know that the increment here is 1. And that is why we put 1 here. So if you run this, you have the same result as this. Let's get the sequence from 1 to 20 with an increment of 0.1. So in R, you can type sec from 1, that is from, then where is going to end? 20, then an increment 0.1. As you can see, this is the result. Now you see that here we have different values. We have 1, 12, 13. Let me tell you what this one means. This is the first element, this is the second, this is the third, fourth, and this will be 11th, and here is 12. So this one is telling you that the first element here is in the position 12. Then you can be counting it from that. And here is 23. This is the 34th position. This is in the 89th position. Let's go down. This is in the 188th position. See 188, 189, 190, 191. Let's assign this. You can look for the history by pressing the up arrow key. Let's call it DE. Let's just assign a name for it. Let's look for the length. The length of DE, the length of DE is what? Oh my god. The length of DE is 191. As I said, this is in the 188th position, 189, 190, 191. So you understand what this one indicates. Now, what about the sequence of number from 20 to 1 with the decrement of 0.1? This is going to start from 20 and decrease to 1 with a difference of negative 0.1. Can you try it? Try it in your editor so that you can have your script saved. Okay, let's see how we can save our script. So you can use this shortcut Ctrl S. Then let's call it new class in R programming. Let's save it. Great, we have saved it. So if you check your desktop, you will see it there. Okay, this is another one. We have done this one before, but let's try it again. This one is a sequence from 5 by 2 with a length of 50. So which means that you want to create a vector of length 50, but you want the element to start from 5 and with a difference of 2. So let's see it. Sec. You know that we have 3 arguments in sec. The first one is from what? From 5. Then by is 2. Then with a length of 50. Length of 50. Then let's run it. You see, this has length 50, but the sequence starts from 5 and with a difference of and with a difference of 7. So let's save it as VCT, and then let's look for the length. The length of this vector is 50, as you know that in the argument we put length 50. So what about this one? Okay, we have done that. Now this is another function called replicate. What replicate does is to replicate this in this. Replicate 5 in 10 times, and that is the meaning of replicate 5 in 10 times. Let's see it in the console. Rep 5 in 10 places. See 5, 5, 5, 5, 5, 5. If you want to replicate your name, what's your name? Miriam. Miriam. In how many places? 50. How old? Quite much. 50. Don't forget that Miriam is a class of what? Character. And that is why we put a double quotation here. If you put only Miriam without quotation, R is going to throw an error. Do you see? We have Miriam being repeated how many times? 50. Alright, great. So what about this one? This one will replicate each element in 3 times. Let's see. Rep 1 to 4, 1 to 4 each is equal to 3. This is 1 in 3 times, 2 in 3 times, 3 in 3 times, and 4 in 3 times. You can get more help by using question mark rep. Do you see? Where you can read through it and see different arguments in this function. Oh, you are asking, what is an argument? Okay, so when you have a function like rep, the input in this rep are the argument. For example, you see it here. Let's look at it. We have x, we have times, we have length dot out. You can read through to understand what it means. We have each, and so on. And those are the arguments in this function rep. I'm going to give you this one as a classwork. So you are replicating 1 to 4 each in 3 times, and time is equal to 2. You can try it out and see what it means. Replicate 1 to 4 in 1 to 4. So what this one is, don't let me tell you the answer, okay? Do this one too. Alright, great. So this is your classwork. In season 3 of this virtual bootcamp, I'm going to do the correction for you. But let me tell you what you are going to do in this place. In the first assignment here, you are creating a vector of a number from 1 to 50. You know you can do that, right? Alright, great. Here, you are assigning all these numbers to a vector called x, and you are going to use R to get its length. Then, after that, I want you to get the sum of x, sum of elements in x, get the mean, and get the variance. Oh, I've not taught you that one. Alright, let me quickly show you. But I'm not going to show you with this assignment. Let's see how we can do that in R. For example, let me say I have a vector of money. I have a variable called money. Let me put element there. Since me say like money, let me assign this to the vector money. This is $50. This is $15. This is $90. This is $85. Now let's see what we have in the vector of money. You see that these are the elements in this vector. Alright. If I want to get the sum of the elements in money, I'm going to use a function called sum. Sum money. As you see, if you add 50 plus 15 plus 90 plus 85, you have 240. For mean, which is the average, so in R, we are going to use a function mean. And let's see the mean of this money. The mean is 60. What about variance? In R, the function for variance is var. So let's see, var money, variance of money. The variance is 1216.667. Okay, great. Now, in this assignment, I want you to draw a beautiful bar chart for vector x. Let me use this one as an example. So how do we draw a bar chart? So we can use a base function called bar plot. Bar over plot number 1, we are going to put this vector there, money, and let's see what we have. You see, this is the bar chart of money. And to make it beautiful, we can use an argument color, which is call. So this is the color I like, so let me run it for you. Now you see this. So let's see another color. Which color do you like? Okay, blue. Right, blue. Run it. You see. Alright, great. Let's continue. Now, with this example, you can calculate number 1, number 2, you can solve it by yourself, number 3, number 4, and even number 5. I think it should be simple by now, isn't it? Oh, great, it's simple. Now, we have another data structure called matrices. What is a matrix? A matrix is a collection of elements of the same data type. It can be numeric, character, or logical. We are going to arrange it into number of rows and columns. That is why a matrix is called two-dimensional array, because it has number of rows and number of columns. For example, let's consider this matrix from 1 to 9, where we have number of rows to be 3, and we are going to arrange it by row. Let's see. A is equal to matrix. Matrix is a function to have two-dimensional array. So in this matrix, we have number of arguments. Number 1, we have data. Data is the vector in which we have here. Number of rows, that is the number of rows in our matrix. In this case, the number of rows is 3. N-call is the number of columns in our matrix. For example, in this case, the number of columns is 3 as well. So this matrix is 3 by 3. By row is how we want to arrange the element in the matrix. For example, in this case, we want to arrange it in a row wise. That is why by row is true. I put T here. R accepts either T or the full boolean true, but I will advise you to stick to true. T R U A. Don't mind me for putting T here. Alright, let's see it. 1 to 9. Our n row, the argument n row is the number of rows, and in this case our n rows will be what? 3. Great, 3. And you can also specify the number of columns, but in this case our n call is 3. We have number of columns to be 3. By row, the fourth argument. By row is that we are arranging this matrix in row wise. So therefore, I'm going to say that by row is equal to true. So let me run it by pressing enter on my keyboard, and let me see what is in A. As you can see here, we have the same matrix here and this place. So this one is that we have first row. So in our first row, the elements there are 1, 2, 3. Second row, the elements there are 4, 5, 6. third row, the element there are 7, 8, 9. And in this place, as you can see here, 1, 1, 1. This one is saying that we have the first column here, and the elements there are 1, 4, 7. This one is the second column, and the elements there are 2, 5, 8. And in this place, this is the third column, and the elements there are 3, 6, 9, as you can see. We can also check the order of this matrix by using dim. So let's put our variable there. As you can see, we have 3 by 3. Okay, great. So let me quickly show another 2 by 2. So can you tell me the variable name for that I can use for my 2 by 2? Oh, as we call it, math. All right, great, math. Then what function are we using for this matrix? Matrix. Oh, great, matrix. As you can see, we have data. So if you like, you can just say data is equal to, then you put your vector there. So you know that we are looking for 2 by 2 matrix, and in that case, we are going to have how many elements? 4. Great, 4. Let's see. So tell me elements that you like. 6, great. 7, great. What other thing? 11, right, 11. And 5, good. So this one we arrange it in 2 by 2. Okay, let's continue to put the other argument. And here you see n row. So after this comma, you can press tab. So this tab will prompt other argument, and here we have n row. So the n row in this case will be what? 2. Good, 2, because what? We are looking for 2 by 2 matrix. All right. So the n core number of column is what? 2. Great, 2, because it is 2 by 2 matrix. That is why when you multiply the n row and n column, you know, is 4. That is why we have 4 elements here. Okay, great. And this by row is how we want to arrange our matrix. So how do you want to arrange it? Okay, column wise. Good. Let's just put first here. So first we make it to arrange it in a column wise. Let's run it and let's look for what is stored in the variable maths. As you can see, now we have our maths to be 2 by 2, as you can see here. Then let me check for the order of this matrix. So what function are we using for this order? Dimension. Good. Dim. Okay, great. And you then put your variable there. As you can see, oh my god, don't mind this thing. It's because we name our variable as math, and you know that when you use math, that is so R will give us quickly put matrix there. Don't mind it. So let's see dimension. Now we have 2 by 2. Great. Let's continue with our slide. Oh, we have done this one. We know the first argument, which is the collection of the element that will be arranged into rows and columns in the matrix. Okay, and you know what by row means, you know what n row means, and you know what n col means. Okay, let me give you this one as a classwork. So in this case, I want you to construct a matrix with 3 rows containing the numbers 1 to 9, filled column wise. Okay, it's like the first example, yes, but in this case, do you know what I'm going to put here? By row is what? By row is false, like this place, so that when this matrix is arranging the element, it will arrange it column wise. Good. Okay. No, the other thing is that we can also put our vector like this and this and use concatenate to combine them together so that you form one vector. Can we try this? Oh, you've not seen this one before. Okay, let me clear my screen by pressing Ctrl L, and let me put this one there. We have row 1 to be a vector of 140 and 134. Then we have row 2 to be a vector of 160 and what? 158. Great. So let's run it. You can look for what you put in row 1. As you can see, row 1 is this, and row 2 is this. Great. Now, this concatenate is to combine this and this together. So which means that you have 140, 134, 160, and 158. Let's see. So you have concatenate, put your row 1 here, and put row 2 here. If you press enter now, you see that you have one vector now. This one, this C, has combined row 1 and row 2 together, and that is why you have this. So we are going to put this thing into a function matrix. Now let's see it. Let me call this matrix my matrix. Okay, and let me copy my code here by highlighting it and press Ctrl C. So use function matrix. Okay, paste that in there. Great. Now put comma there and press tab to see the other argument. So what is the other argument? N row. Great. N row. So that is number of row. You know that this looks like 2 by 2 matrix, and here we have n row to be 2. Good. And then you know this we have how many columns? 2. Okay, n col is equal to 2. Then you put comma, and you can also press tab to see other argument. And here now the other argument is by row, and you want to arrange it what? Row wise. So just say by row is equal to true. Good. Okay, let's press enter. Then let's see what you have in this variable matrix, my matrix. As you can see, it's also 2 by 2. And you can also check for dimension. Can check for dimension by using my matrix, the variable my matrix. Is it clear now? This is 2 by 2. Good. Okay, I know you can do this one, right? It's very, very easy to have this. Good. So this is also another example. Okay, you are saying that we don't have n row here. Yes, it depends. You know, if you have number of columns to be 3, so this function will automatically accept n row to be 3. You can try it to see that. Good. So how do we select element from a matrix? Before, you know, in the vector, we know that we can extract element out by using a single square bracket. So for example, you know, we have row 1, the other vector that we did the other time, and this. And if you want to extract this 134 out, we are going to do what? We are going to do what? Okay, you say row 1, you put a square bracket there, and the index of this 134 is what? 2. Great, is 2. And now you see that we have this. But in the case of a matrix, you know that matrix is 2-dimensional array, and that is why we are going to have something like this. Okay, and the first one will be the row, and the second one is the column. As you can see, this indicates the position of the row and the column in which the element to select is. Okay, let's see what you have in, let me clear this screen. Let's see what you have in the matrix A. So you have this. Okay, if you want to extract these 2 out, okay, you know that this 2 is in the first row, right? Great. and also it's in the what? Second column. Great. Good. You are doing well. Great. Let's see. A square bracket. Okay. Now the first order is what? You see, it's in the first order. Press 1. Good. Separate it with a comma. Good. To put the second the column at which this 2 is. As you can see here, this 2 is in the what? Second column. Good. Let's put 2 here. Okay, let's put 2 here and press enter. You see, now we have this 2. To get this 7 is in the third row, right? And first what? Column. Great. Let's see. A third row, 3 separated with a comma, and this 1 is in the first column. So put 1 here and press enter. Can you see? Great. Good. So can you extract this 8 for me? Oh, you are saying that A will be, this will be third row, 3 separated with a comma, and then what? Second column, 2. Oh, great. So that is how to select element from a matrix. Okay, before we go to the arithmetic operation in a matrix, you are asking, how can we what? How can we select 2, 3, 5, 6 from a matrix? This one. Okay, great. So it's very easy. Let's see how we can do it. So we put our matrix there, A. I put a square bracket there. You know that here for this one, this and this is in the first row and second row. So we are going to use concatenate to separate these rows from others. So now we are going to use concatenate 1, 2 because the first 2 are in the first row and second row. Okay, so then you go out and put comma there. Then for this column, you see this is also in the second column and third column. So therefore we are going to use concatenate to combine them together, because if you don't put concatenate here, as you know in vector, that this will throw an error. So therefore we are going to put 2 here, comma 3 here, and then after everything you press enter. As you can see, we have 2, 3, 5, 6, and that is what is here. 2, 3, 5, 6. Is it clear? Can I continue? Great. We can perform so many operations in a matrix. For example, we can do addition. So what you are going to do in the addition is that you have 2 matrices, A and B, and you put this sign there. Okay, I should show you with an example. Okay, let's see. So let's say we have matrix A, which is a 2 by 2. Let's say matrix, you know the function is matrix, then it's a 2 by 2, right? Let's put the element there. So which element do you want us to have there? 2, 5, 7, 9. All right, great. So this is a 2 by 2 matrix. Put comma there and put n row there. N row is 2. Good. N call is what? 2. Great. And you want to arrange it by what? By column wise. Okay, so we put by row is equal to false. And let's see what you have here. You see we have A here like this. Okay, and then we also have, let's say we have another matrix B. Okay, let's put the elements there. Matrix. Okay, great. So now we have concatenate. All right, it's a vector. So what elements do you want to be in B? 10. Okay, 10. What other one? 4. 7. Okay, great. 7. Which one again? 15. Oh, 15. Okay, great. So now let's put number of rows. How many rows? Okay, 2. Okay, this should be 2. And how many column and call? 2. Great, 2. And you want to arrange it what? Row wise. Good. By row is equal to true. By row is equal to true. Then B, so this is B, right? Now you can perform addition. So what addition does is to add the element row wise. So this will be 2 plus 10. This will be 7 plus 4. This will be 6 plus 7. And this will be 9 plus 15. Let's see. Okay, great. A plus B is that, as you can see. Oh, you can see clearly. Okay, let me scroll this one up. You see, this is 2 plus 10 is 12. 7 plus 4 is 11. 6 plus 7 is 13. And 9 plus 15 is 24. That's how to do addition. So let's go with the slide again. For subtraction, it's just the same thing. Let's say A minus B. As you can see, this is it. For multiplication, so in R, to do multiplication, you have to include this function there. You are not going to use the normal multiplication, because what the normal multiplication will do is to multiply the element, is to do it element wise. That is the way we did it for addition or subtraction. Okay, but it's not like that. You know that there's a special way at which you do multiplication in the matrix. Okay, let's see how we're going to do this one. So for A times B will be, so you are going to use percent, put multiplication sign there, another percent, and then put B there, and then you have it. As you can see, this is it. But if you use ordinary multiplication, so this is not correct, because this is going to do it element wise, and you know that is not how we do it for multiplication. Okay, let's continue. Now transpose. You know, transpose is to arrange the element from row to column. So this is the first row, it's going to be the first column here. This is the second row, it's going to be the second column here. And this is the third row, it's going to be the third column here. That's how we do it for transpose. And the function for transpose in R is T. So let's use A. For example, we have, let me clear my screen to see it clearly. We have this matrix A, and then you can use T A to transpose it. Okay, let's continue. For determinant, okay, you know, this is the symbol for determinant when you put it in line like this. And then to get the determinant in R, you use det. So let's see, you use det of which matrix? B. And the determinant is 122. Data frame. So you know, we have done how many data structure? 2. Okay, great. We have done for vector, we've done it for matrix, and now this is data frame. So what is a data frame? Data frames are another way to put data in tables. Data frame is like your normal Excel, where you put data in rows and columns. Unlike matrices, data frames can have different types of data. As you can see, that when we have matrix, let's say matrix A, you see that everything is numeric. Both rows and columns are all numeric, as you can see the elements here. But in data frame, your first column can be of type character, while second column can be of type numeric. A data frame has the variables of a data set as columns and observations as rows. A data frame has the variables of a data set as columns and observations as rows. This will be a familiar concept for those coming from different statistical software, e.g. Excel, SPSS, or Stata. So let's see how data frame looks like in Excel. Let me open my Excel so that you can understand what I'm saying. So for example, you have Excel like this. Okay, let's say you have height of a student, and the gender. Okay, gender. So let's assign different heights. Okay, you have what? Let's just put any number there. 15, 18, 17, 16, and 19, 17. Okay, let's assign the gender. Female, male, male, female, then male. As you can see, in this place we have how many columns? We have 2 columns here. And how many rows do we have? We have how many rows? So let's count it from here. 1, 2, 3, 4, 5. We have 5 rows, as you can see. So this one we have 2 columns and 5 rows, and this is a data frame in R. So let's see how we can do the same thing in R. As I said before, the function for data frame is data.frame. Let's see example. But I'm going to use height and weight instead of height and gender as you have it in Excel instead of this example. So let me use editor to do that. Okay. So now let me put it in a variable data. Okay, I'm going to have data dot frame. Okay, and my data will be in 2 columns. So the first one is height. So I'm going to put height there. Height. And you know height is a vector. That is why every column in the data frame is a vector. Every column in the data frame is a vector. So let's put it there. We have 5 observations, and that one will be our number of rows. So let's say for the first height we have 17. Don't mind the number, but just it's an example. 17, 19, let's say 24, 16, and 13. Okay, this is the first column. And then the second column, after you are done with height, then we are going to use another example called gender. So gender is equal to, gender will be of class what? Character, grade, character. So therefore, everything we put in this vector will be in double quotation. So let's see it. We have female, we have male, we have female. Okay, great. With quotation, female. We have male, and we also have female. Good. Now, after this, we can press Ctrl Enter to run it. Now, let's see what is in variable data. Oh, this one is not in quotation. Let's see what you have in data. Oh, that's great. So in the data frame, we don't use this our normal assignment. We are going to use is equal to the other assignment for this in the data frame. But if you are assigning a variable, you are going to use this assignment. But anytime you are assigning another vector in a data frame, you are going to use this assignment. Okay, let's see. Data, as you can see, we have a data frame now, which is of 2 columns and 5 observations, and that is why we are saying here that a data frame has the variables as columns and observations as rows. Is it clear now? Yes, good. As I said before, that each column in the data frame is a vector. As you can see here, this is a vector height, as you have height here. This is a vector height, and this is a vector gender, and we put them together with this function data.frame, so that we can have it in this format. Okay, you are asking for this number. Okay, these are the row labels. For example, we have 1, this is the first row, second row, third row, fourth row, and fifth row. Oh, R is awesome. Great, great. Thank you. R is awesome. So it's very simple to learn. Okay. Can you do this one for me? So what you are doing here is to create a vector gender, and gender in male, female, and female. Then we are also creating another variable age. Okay, so we have 2 vectors, gender and age, which will be columns in the data frame. So after you put your function data.frame, then you are going to put your vector in it, and the output is what I'm looking for. Can you do it? Oh, I will do it for you. Okay, let's do it together. Gender is equal to male, female, and male. Okay, good. And age is equal to 17, okay, 25, 14. Can you tell me why do we put these elements in double quotations and we don't put this in double quotations? Okay, because this is of type character. Yes, it's true. And that is why we don't put double quotation here, because this is of type numeric. Great. So let's run the two together. Okay, and then we want to convert this to data frame. So that is why we are going to use data.frame function. So, and you put those vector in the argument of data.frame. So you have gender and you have age, as you can see it here. So when I use Control Enter to run it, we have our data frame here. Is it clear now? Good, it's clear. Great. So this one, let's do it together again. It's a group work. Can you form a team of 5 members? All right, great, good. So let's do it together while you are in a team. So in this work, we are creating a data frame. We are going to name it data, and we are going to use the following vector for it. You are asking, what is set.seed? Okay, set.seed is a function in how that will make you to have the same data set. Why are we doing that? Okay, because we are using this function rnum. So we are simulating a data with 5 observations that has a mean of 135 and standard deviation of 12. That is why we have this function rnum to simulate. Okay, you don't know what rnum means? Okay, let's check what rnum means. Rnum. To look for help in R, you have to use question mark and the function name without parentheses. Do you see now? This is a normal distribution, as you can see. So you can read through to get what you are looking for. But the function that we are using here is rnorm. As you can see, n is the number of observations that we want to simulate, and we want this data to follow a normal distribution. To follow a normal distribution. As you know that normal distribution has what? Two parameters. Yes, the first parameter is the mean, and second parameter is the variance. And you know that variance, standard deviation, is the square root of variance, and that is why we have SD here. So let's quickly generate this. Set.seed. So you can put any number that you like that is numeric here. Let's say set.seed is equal to what? 49. Great, 49. Let's run it. Let's put this one here so that we have it saved later. So we have set seed, and then we are simulating for 100 observations that has mean of 135 and standard deviation of 12. Let's see. Height follows normal distribution rnorm. Then you see n, our n is the number of observations. In this case, I want to put 100 here. That is, I'm looking for 100 observations that has 100 observations that have a mean of 135 and let's see, let's put them together so that we can see what we are doing clearly. That have a mean of 135 and standard deviation of what? Of 12. Good. Let's see. So when you run this one, you can quickly check what numbers have been generated in this height. Let's see. As you can see, we have them like this. And if you also want to look at the distribution of this, whether it is true that it follows a normal distribution, you can use a function histogram to see the distribution east of height. Let's quickly do that. East is a function to plot our histogram. So let's run it. As you can see, we have this. Wow, this follows a normal distribution. Yeah, it is true. Don't forget that this function also accepts color. So you can use color. Which color do you like? Yellow. Great, yellow. So let's see. Great. As you can see, we have a yellow function here. Don't forget you can zoom. You can also zoom out. Can you see? Oh, you see? It follows a normal distribution. Okay, great. So I'm just showing you it's not part of what we want to do. Okay, and the same thing with weight, because it is believed that height and weight follow a normal distribution. So let's say rnorm, let's generate data for it. Rnorm is also 100 observation. Don't forget that both of them must have the same number of observation. Why? Because we are creating a data frame, and every column in the data frame has the same number of observation. Don't forget that. It is very, very important. So n is equal to 100 and mean. So we want this distribution to have a mean of 55 and a standard deviation of 9. So let's run it. Don't worry, it's because I put I squeeze my house to do. That's why this one is coming out. But if you look for what I have here, you see that my variable, these values have been assigned to a variable weight. You see, it's because of the way I squeeze the house studio. That is why this one is complaining. See, it's telling me that it is too small. Okay. Don't forget, you can also clear your screen for this place by coming here, clear screen. See, yes, that one has gone. So let's clear the screen. It's already there, but let's run it again. You see, because of the way I squeeze this. Okay, great. So now we have our weight and height. All right. So because I have set seed, so if I call for weight again, I will have the same simulation. So let's run it together again. Good. So let me look for height. As you can see, we have this 130.88. So if you run this one again and call height again, you will have the same set of simulation. You see, 130.8808, 130 point. So this one is happening because of the same seed that we have. If you don't set a seed, then this one will generate different numbers for you, as many as you are pressing this Control Enter. Is it clear now? Great. So let's quickly create a data frame. So we are creating a data frame with a variable data, and then we use data.frame, and then you put your vectors there. Don't forget, we have two vectors, and they are what? Height and weight. So we have height and weight. Good. So now we have formed a data set. Let's see what we have in our data set. So you see now, it's a data set that have 100 observations and what? And 2 columns. As you can see, we have 2 columns with 100 observations. And you can also check the order of this data. So by using dim, and you can put your data set there. Dim data, as you can see, is 100 by 2. Is it clear now? Great. How do we check the overview of our data set? Okay, it is not a good practice to create a data frame and then open everything. If you have more than 1 million rows of observations, then it is possible that your R Studio will crash. And that is why we have these 2 functions to check what is in the head and what is in the tail. Let's see it here. Head is a function to see the first 6. Let's see data. You see, this is the first 6. Height and weight, you see, this is the first 6. And then a tail enables us to print out the last observations in our data set. So with a function tail data, you see, we have the last 5 observations. As you can see, both head and tail print a top line called header, which contain the names of the different variables in your data set. Don't forget, the good practice is to assign your data frame and then use head to check the first 5 observations and then tail to check the last 5 observations. Is it clear? Good. Okay, to look for the structure. So what is the class of this height? What is the class of this weight altogether? So we use a function called str. This str will show you the structure of your data set. Let's quickly see it. Str data. See, str data gave us a lot of information. For example, it gives us the total number of observations. So in this case, we have 100 observations. It also gives us the total number of variables. As you can see here, we have 2 variables. A full list of the variable names. In this case, we have height and weight. The first observations, as you can see, these are our first observations for height and for weight. Applying the str function will often be the first thing that you will do when you receive a new data set or a data frame. It is a great way to get more insight in your data set before diving into the real analysis. As I said before, if you have a big data set, you cannot just call out for that data set. Automatically, your R Studio will crash. And that is why we have these 3 functions to help you. Head to see the first 6 observations, tail to see the last 6 observations, and structure to see the overall information in the data set. Oh, it's simple now. Thank you. So as you can see, we also have another example. Here we are using cell seed 1, 2, 3, and we are creating 2 vectors. Both of them follow normal distribution, and they have the same observations but with different parameters. As you see, this one has a mean of 155 and standard deviation of 13. This one has a mean of 69 and standard deviation of 11. I believe you can do this by now. Can you do it? Yes, great. Thank you. As you can see, after I did it here, I have my head here and I have my tail here. Oh, you are asking, what is this file? Okay, so this is another argument in head function. This one is showing that I want 5 observations. This one is showing that I need the last 3 observations, as you can see. So we have it here. R has several inbuilt datasets. So you can call for this function, and this function will list all the datasets in your R. Let's see. So by using data then function, this is the function. Don't mind our variable name that we have used before. Okay, as you can see that we have never used this kind of function before. So this one will open another window for you to see various datasets that you can play with. We have quite datasets here, as you can see. So let's quickly use one. For example, let's use this BJ6. So, and this is the information about the dataset. Save data with leading indicator. Can we try it? All right, let's try it. So how do we select this? So we can use the same function, data, then come here and then take BJ6. As you can see, that's automatically come. So just click on it and then you have it now. So how can we now use it? Okay, we can just call it data frame. So let's use this variable name and then call it BJ without any double quotation. Let's see. So we have it here now. So if you run it and then look for data fr. So because I know that this data set is not big, that is why I am opening it like this. Oh, this is not like a data frame. This is another data frame. This is a time series. So let's check for another one. So let's look for this cheek weight. Okay, I've told you how you can do that. So you're going to use this function data, okay, then put the variable name there, the data that you are looking for there. As you can see, once you use this function, okay, automatically R will prompt a lot of data sets for you, and in this case I want cheek weight. So then I press enter. Then I can assign this to my variable. Let me call it chicken, because Tomisi likes chicken. So let me use chicken here. Okay, and then I put this one without quotation, chicken. Automatically it has come. So let's see. Now I know that this data set is quite small. So let me see what is in my chicken. Let's see. Now R has reached its maximum, and that is why it has omitted 328 rows. But let's scroll up to see what is in this data set. Who can tell me how many variables do we have in this data set? Oh, 4. Great. We have 4. We have weight, we have time, we have cheek, and we have diet. And how many rows do we have? You don't know. Okay, so let's use our dim function to get it. Dim is dimension. See, dim, and then the name of the data set, chicken, the variable name chicken. As you can see, we have 578 observations, and we have 4 variables or 4 columns. Is it clear now? Can we check the head? Okay, let's see. Head chicken. Don't forget that R is case sensitive, and you have to know the right data. If you take this one, you are doing another thing. But this is our variable name, chicken. So you see, this is the head, and you want the tail, you can also do it, tail, chicken. As you see, this is chicken. Is it clear now? Okay, great. What about structure? Okay, we can use it. str chicken. Str chicken. What is it? So you see, this is it. So this is data frame with 578 observations and 4 variables, and we have our variable name. This our variable. Yeah, our variable. This is weight. This is time. This is cheek, and we also have another one, diet. Don't forget the class of object for weight. This is what? Numeric. What about time? Numeric. What about cheek? This is a factor, but this factor is order. That is why we have ord dot factor. As you can see, these are the levels in this chicken, in this cheek, but they are ordered. As you know that 18. Okay. Yeah. So this is saying that 16. If you put it like this, okay. Let's see how we can do that. Let's see how we can do that. Okay, I think we have how to. Okay, let me show you how we can do it. How do we select a particular variable out of this data frame? So I want to select this cheek out of the data frame. So there are many ways at which you can do it, but the first way is use the variable name chicken, okay, and then this, you see, we are going to use we are going to use a square bracket as well. Square bracket, then this is the first, this is the row, then separated by column. We have row here and column here. Is it clear? And if you want all the observations, and then this one will be empty, you not put anything here. And this one is the column that you want to extract. But in this case, because I want to check what is in this cheek, so I'm going to use, I know that this is the first column, second column, this is the third column. So in this chick, this will be 3, right? 3. And once you do this, this one will become a vector. It will not become a data frame again because you have selected this column out. Let's run it. As you see, this has become a vector. Is it clear? And now, as I said, this has 50 levels. Okay, and this one is saying that 18 is less than 16, 16 is less than 15, 15 is less than 13, 13 is less than 9, and so on. Is it clear now? Okay, great. So what about other columns? How do we select this weight out? It's the same thing, because we are looking for all the observations and then we want to get the first column weight, and in this case you will change it to 1, and then you have this one as weight. And don't forget, you can create a variable for it, call it weight, and assign this to this. Is it clear now? And you can check for weight. See now, and you can also look for the length of this weight, because this is a vector, this is a vector, and you can check what is in this weight. You can check for the length of observations. So this is 578. Is it clear now? Okay, you are asking, how can we select 2 variables, right? Okay, great. Okay, let's quickly look for the name of variables in this data. You know, we have this data as chicken. So let's see, to get for the name of variables, so we can use names. This is another function called names, and you put the variable there, chicken. Our data is chicken, so let's put it there, and by this we can also get the names of columns in this data. As you can see, we have 4 columns, and the names are weight, time, chick, and diet. Is it clear? And don't forget, you can also use str. str will show you what's the name of the column, the number of rows, and the structure of each of the columns. As you see, each of the columns, you see, you know that is 4 variables, and these are the names, and these are the structure. Is it clear now? As you clear my screen, okay, good. All right, so now we know how to use some inbuilt data sets in R, and we can do that by using this function. Is it clear? Good. So another data structure is called a list, and let's see what is in a list. A list in R allows us to gather a variety of objects under one name, and that is the name of the list in an ordered way. These objects can be matrices, vectors, data frames, even other lists. It is not even required that these objects are related to each other in any way. Unlike data frame, in data frame, so you have a particular variable, and every observation in that variable must be of the same class. For example, let me see this one. Let me come to the console again. Let me look for the head of this chicken so that you can understand what I am talking about here. Do you see? And let's call a structure to help us to understand this list. Let me scroll up. You see that we have weight here, and weight is of class what? Numeric, and everything there must be of the same class. You can't have 42 here and have female here. It's not possible for a data frame. And now you see, this is time, this is also numeric, This is chicken, is of the type factor. So the class here is factor. Okay, and diet too is of class factor and has how many levels? 4. These are the levels in this diet. Is it clear? Now you see we have how many class of objects we have? We have numeric 1, we have factor 2, another factor 2. So we have just 2 classes in this data frame. But in the list can be matrices, vectors, data frames, even lists altogether. Is it clear now? Let's see it with an example. So the function for list is this: list with parentheses, and you put your data here. The argument to this list may be a matrices, as I said, data frame. It can also be a vector, and this is what you call list components. So whatever you put here is called list component. Is it clear now? Okay, great. Let's see it with example. Let me come to our data source, our editor. Okay, let's see it with example. Now we have a list, and this list contains age, sex, and pass. This pass means whether the student pass or not. You see, this is pass. So let's do it. Let's try it. My list. So we are going to use this function list. Then we put parentheses and we assign this component into the list. For example, age. Let's say the age is what? Oh, sorry, with no quotation. Yeah, you are good. 19. And then sex. Don't forget that sex is a character. That is why we put it in this character format. And then pass. And pass is Boolean. Don't forget, it's logical. And that is why we have this true with no quotation. If you put it in quotation, then that will become what? A character. Yes, it will become a character. Great. So this is a list. So let's clear this screen to see it clearly. This is a list, and then we can check what is inside this list. My list. Do you see? We have age to be 19, we have sex to be male, and we have pass to be true. Is it clear now? Great. Let's do it with other example. Let me use Ebon lists, or let me put it Ebon underscore list. Okay, and I'm going to use a list function. So in this list, Ebon has different currency. So money in a vector. So let's put this in as a vector. So add different currency. For example, she has dollars in her account. She has naira. Let me use naira. Okay, this is not naira symbol, but let me just use it so that you can understand what I am saying. And then there's no other currency that I can use in my keyboard. Let me say she has just 2 currency, dollars and naira. Okay, and this is for this vector. But for matrix, okay, so let's say math, and in this place I want to assign matrix to it. Oh, she's telling me to use 2 by 2. So matrix 2 by 2. You see, we have 1, 2, 3, 4, just to make it simple. And then n row to be 2, n colon, don't forget to be true, 2 as well, and then by row to be false, Is it clear? And she also has a data frame, so data frame iris, and because iris is already in R, so this is dataset iris. You can also use dataset like this, iris. As you can see, this is iris, and now we have data frame iris. As you can see, it has how many columns? 5 columns. This is separ length, separ width, petal length, petal width, and species. Let's use structure str to do it. Iris. To see 5 observations. So let's use iris, and let's run it to see what is in Ebon's list. Now let's say Ebon list. So it's quite much, but let's see. Number 1, we have money. As you can see, we have dollars and naira, and she also has a matrix that is 2 by 2. As you can see, this is matrix, and these are the elements in this matrix. And then dataset iris. As you can see, this is iris, and these are what is in this iris. Is it clear now? That is how we use lists. But how do we extract individual elements or components of a list? You can extract individual elements of a list by using a double square bracket. For example, in this Ebon's list, you can just extract this money out by using this Ebon list. Okay, double quotation. I want to extract the component money, and the money is in the first as index 1, so I put 1 here, and then if you run it, as you can see, this is what is in this money, dollars and naira. As you can see, for matrix, okay, we are going to change this one to 2. Do you see? And for dataset iris, data frame iris, we are changing this one to 3. Is it clear? Okay, great. You may have noticed that we have used double square brackets. If you use a single square bracket, this will obtain a different result. Let's see, Ebon list. Let's change this one to a single square bracket and put 1 here. See, this one will extract the component with its name. As you can see, this has dollars and naira, and the variable that has this is money. And for a matrix, just change this one to 2 and run it. As you can see, matrix, and you have this. Is it clear now? The difference between this double square bracket and a single square bracket. A double square bracket will extract the element for the component, and while a square bracket will extract the element and the name of the component together. As you can see it here, the elements and the name of the component. Is it clear now? Okay, great. Okay, how do we check if this Ebon list is of the class list? Don't forget that we can use class to get the object class. So let's come here and use class. Ebon list. As you can see, this is telling us that this is a list. And we can also see the difference between the first component and the first okay, one square bracket and double square bracket. Let's see. In this case, we know that Ebon list for this component so gives us a matrix, elements, and name of the matrix. But if you come here and put class here, this is telling you that this is a list. As you know that if you come here and say Ebon list and put 2 here, this shows you that this is a list. But if you put the square bracket, the double square bracket here, okay, this is no longer a list. As you can see, this is a matrix because it's extracting all the elements out. Let's copy it and paste it here. As you see, this is a matrix and it's not a list. And that's the difference between the single bracket and double bracket. A single bracket will return a list. As you see, the elements including its name, while a double bracket will only extract the elements in that list. As you can see, this is dollars and naira, and you know that this one is inside the money. Is it clear now? Great. It is important while extracting individual elements or components of a list. How we throw an error if that index is out of band? Let's see. You know that this list has how many elements? Has how many components? 3. We have money, we have math, and we have dataset iris. Okay, you can also check length to get it. Length, and press and type Ebon list. As you can see, this Ebon list has 3 components. Okay, and you know how to check for the components. So you see that here we have iris dataset, we have matrix, and we have money. Okay, so and we know that if I put 1 here, it's going to give me the first complement. Use single square bracket. This one is going to give me the first component, and this one is going to give me the second component, and this one is going to give me the third component. So what will happen if I put 4 here? And you know that the length of this list is 3. So if I put 4 here, R is going to throw an error saying that it is null. And if you also put a square bracket here, R is going to tell me what is happening. As you can see, subscript out of bounds. Why? Because this list is of length 3, but I put 4 here, and there is nothing in this index 4, and that is why it is out of bounds. Is it clear now? Okay, great. So let's quickly see what we have done so far. So in this tutorial, we understood how we can download R and R Studio, and we also know the difference between R and R Studio, and we also learned various atomic data types. Can you tell me? Okay, numeric, character, factor, boolean. Great. And can you also tell me the various data structure that we have in R? Vector, yes. matrix, yes, data frame, yes, and a list, yes. So by this we come to the end of today's class. Thank you.